Solve and graph your solution. Write your answer in interval notation. We have the expression 6x squared plus x is greater than 2. This inequality has more than just one variable, so in order to solve it we need a 0. So let's subtract 2 from both sides of the inequality. 6x squared plus x minus 2 is greater than 0. The way that we solve a problem that has too many variables in it is to try and factor. We factor by taking out what's common first. There's nothing common. We break down the first term. We have a couple of choices. We can use 1 and 6 or 2 and 3. So let's start at the end of the list with a 2x and a 3x. We also break down the last term, 2. There's only one way to break that down, is a 1 and a 2. But since there's nothing common, we shouldn't put the 2 together inside the same parentheses. So we'll put 2 in the other parenthesis. We'll check the signs. They're supposed to be different, but the result is supposed to be positive. So if I have a positive 4 and a negative 3, that'll work for us, and that's still greater than 0. But it's really hard to do an inequality problem. It's much easier to do an equation. So we would have our 2x minus 1 times 3x plus 2 equals 0. So if we try and solve an equation, zero product property says that one of the factors, if when you're multiplying and you get 0 as an answer, must be 0. So one of these factors, 3x plus 2, could equal 0. Now we're going to solve the simple equation. We'll start by adding 1 to both sides of the equation. We have 2x is equal to 1, and then we can divide both sides of the equation by 2. And x is equal to 1. That's one possibility. Let's look at the other one. We can add a negative 2 to both sides of the equation. We get 3x is equal to negative 2. And we can divide both sides of the equation by 3, which is the same thing as multiplying by 1/3. X is equal to negative 2/3. So these are kind of interesting numbers. They're a little hard to put on a number line. If I had a number line, I would need numbers like negative 1, 0, 1, and 2. Then I can just put these numbers in where they belong. A half is somewhere between 0 and 1, so I can stick in a half. And negative 2/3 is somewhere between 0 and negative 1. Negative 2/3. So it's important that when you're making a number line, your numbers are evenly spaced. And then if you need to put in more numbers to show me where those are, that would be fine. Now the numbers we found were a half and negative 2/3. We're going to try and test back in the original equation to see which numbers make this true. When we test numbers, we never use the numbers that we find. So I'm going to test numbers on all sides. I'll test negative 1. Something between these two numbers is 0. And then I'll also test something on the other side of a half, which is 1. And I test them in the original equation, inequality. So I'll put negative 1 back in the original equation and evaluate this. Negative 1 squared is positive 1 times 6 is 6, plus negative 1 is 5, and 5 is greater than 2. So that's yes. That means that where negative 1 is, that's going to be included as part of my answer. And everything else that lives on the left of the number line. Now I'm going to put 0, another number I'm testing, in the original inequality and see if this is true. 0 squared is 0 times 6 is 0 plus 0 is still 0. Is 0 greater than 2? That's no. So there's no shading here where the 0 lives. And lastly, I'll test a number on the other side of the number I found, 1/2. Testing 1. 1 squared is 1 times 6 is still 6, plus 1 is 7, and 7 is greater than 2. So since 1 is true, everything that lives on the right-hand side of the number line, after the number that I found, is included. They also want us to write this answer in interval notation. So we're going from minus infinity to negative 2/3. That's not included because our inequality was strictly greater than, didn't say or equal to, and we unite this with the other piece of the graph, which started at 1/2 and went to positive infinity.